All right, in this part two, let's pick up where we left off. We found that there was 1.1 amp going through this battery because when it was hooked up to these three resistors, it had a total of 60 over 11 ohms worth of resistance, which is like 5.45 repeating. We found the current by taking the battery voltage of 6 volts and dividing it by that equivalent resistance to get 1.1 amp. And we said that current was going to split once it got to this junction. Some was going to go over R1, some was going to go over R2, and some was going to go over R3. In order to figure out how much, we're again going to use Ohm's law, right? So we're going to use this exact formula, but we have to look at it from a different angle, right? So if you remember from the visualization video, the battery basically took everything over here up to a voltage of 6 volts, and everything down here was at 0 volts. And so that means that across each one of these resistors, I have 6 volts, right? Everything that is attached in parallel has the same voltage across it, okay? So the battery voltage of 6 volts, easy for me to say, is being impressed across each one of these resistors. And so we're just going to use this calculation for Ohm's law to find the current through each one of those resistors. So resistor R1 has a resistance of 10 ohms. So where can I put this? Let's put it right here. So current through resistor 1 would be 6 volts over 10 ohms. And so that's just going to give you 0.6. For I2, we're going to take 6 volts and divide by 20 ohms. And that's, of course, going to give us 0.3 amps. And then for R3, we'll do 6 divided by 30. And that'll give you 0.2 amps. Okay? And now, again, we're going to use Kirchhoff's rules to make sure we're on the right track. Right? Kirchhoff's rules say that the current entering a junction has to equal the current leaving that junction. So we've got 1.1 amps flowing into that point. And then 0.6 plus 0.3 plus 0.2, that adds up to 1.1. So I do have a total of 1.1 amps flowing out because I had 1.1 amps flowing in. So it does check out. Also, just if you wanted to also find the voltage using Kirchhoff's loop rule, you would say, excuse me, I go up through this, I gain 6 volts, I come around here, I have to lose 6 volts to get back to 0. So I must have lost 6 volts across R1 if I take this inner path. If I take the middle path, I gain 6, I have to lose 6 across R2 to get back to 0. I gain 6, I have to lose 6 to get back to 0 through R3. So no matter what path you take, you have to lose 6 volts across any one of those 3 resistors. Okay? I hope you found this helpful. Again, we're just using Ohm's law over and over and over again. Sometimes we're going to use the reciprocals to find equivalent resistance, and that'll of course be for parallel resistors. Sometimes it's just a straight sum, and that's for series resistors. I'm going to post a suggested activity. If you have any questions on any part of it, either leave them in the comments, not on YouTube, but on our Schoology page, and I'll be glad to help you through those. Also, if there's a good time for you to meet over Zoom, let's make that happen. A lot of times having a live conversation is much more useful than just watching a video. Okay guys, stay safe. We'll see you.